This chapter is tangents and normals and what is the application of derivatives here. For learning this, you have to learn first some previous knowledge. That is, first is slope of a line. Slope of a line usually denoted by M is, see, if this is a straight line making an angle theta with the positive direction of x-axis, then slope equal to tan theta. And there is one more formula for finding the slope of a line. Suppose we have 2 points x1, y1 and x2, y2. Then slope equal to difference in y coordinates by difference in x coordinates, or it is y2 minus y1 by x2 minus x1. Then another concept which you have to have is how to find the equation of a line. If x1, y1 is a given point on the line and m is the slope of the line, now the equation of the line, for finding the equation of the line, we should have a variable point xy, and if xy is a variable point, then the equation of the line is y minus y1 equal to the slope m into x minus x1. Then the application of derivative here is, suppose we have this curve y equal to f of x and there is a tangent. What do you mean by a tangent is, it is a line, straight line which touches the curve only at this one point. That is what called tangent. And what do you mean by normal? Normal at P is the straight line which is perpendicular to the tangent. This P is known as point of contact of the tangent to the curve. Now, if you know the equation of this curve, that is, the equation of the curve is y equal to f of x. From the equation of the curve, you can find the slope of the tangent at the point of contact pxy. That is, slope equal to this dy by dx. This dy by dx you are finding out from the curve. From the equation of the curve, if you find dy by dx, what we get is slope of the tangent at the point P. At the point P. If you only find dy by dx, that means it is the slope of the tangent at xy. Now, how to find the slope of the normal? Slope of the normal is the perpendicularity condition of two lines you have to apply. If you know two lines are perpendicular, one is this line having slope m1, another is a line perpendicular to this is 90 degree and its slope is m2. Last year we have studied that product of their slopes is equal to minus 1. If you apply this property here, the normal is perpendicular to the tangent. The slope will be, slope of the normal is minus 1 by the slope of the tangent, because from here, from this equation, you can say that m2 equal to minus 1 by m1. So if you know slope of the tangent, you can find the slope of the normal. So what is the slope of the tangent is? From the equation of the curve, you can create or you can find the slope of the tangent at xy. Simply, you find the first derivative, that is dy by dx, from the equation of the curve. Now, how to find the equation of the tangent? to find the equation of the tangent, you should know how to write the equation of a line. Equation of a line is y minus y1 equal to m into y minus y1 equal to m into x minus x1 if the line passes through x1, y1 and having slope m. So the only difference here is x1, y1 is always taken as the point of contact, that is P, and this m is to be taken from the equation of the curve, that m is the slope of the tangent at xy or at P, you can say. Similarly, equation of normal, that is also the given point on the normal is x1, y1 and slope is minus 1 by dy by dx at P. Then equation of the normal is y minus y1 equal to the slope m into x minus x1. In case of the normal, the slope becomes minus 1 by dy by dx. And some more concept you should know is, if two lines are parallel, their slopes are equal. m1 and m2 are the slopes, and if they are parallel, m1 equal to m2. And slope of x-axis is equal to 0, because that is, by the definition of slope, it is tan theta, and theta is inclination of x-axis with x-axis, so it is 0. So once again I am telling you, m equal to tan theta, that is a basic definition of slope, and also m equal to y2 minus y1 by x2 minus x1 if the line passes through the 2 points. And there is one more formula which we have found out in the calculus is m equal to dy by dx at P, where m is the slope of the tangent. Slope of the tangent to the curve at P. Okay, by looking into that, now we can go to the problem solving part. The first question is, the tangent to the parabola x square equal to 2y at the point 1/2, this is a point which is in the coordinate form, makes with x-axis an angle of the tangent to the parabola. So immediately what you do is, you will draw the parabola x square equal to 2y, and what is given is tangent to the parabola at the point 1, 2. That means this 1, 2 is the point of contact of the tangent. Again, you can check it also whether 1, 2 is a point on the parabola or not. So this point is 1, 1 by 2. 1, 1 by 2. You can see here 1 square equal to 2 into 1 by 2. So this satisfies the equation. So it's a point of contact only. Now the question is, it makes an angle with x-axis. Suppose your x-axis is like this. Your x-axis is like this. Then what is this angle? Theta. So you can see that if this is x-axis, tan theta means we know it is slope. M equal to tan theta. We have to find out the value of theta. Now you, from the calculus, you know how to find the slope of the tangent from the equation of the curve. It is dy by dx, which is to be found from equation of the curve. So to find dy by dx, first you write the equation of the curve, that is x square equal to 2y. Now you find dy by dx. For that you have to differentiate the equation both sides with respect to x. So you will get derivative of x square 2x is equal to 2 into derivative of y is dy by dx. Therefore, dy by dx is equal to 2x by 2, which is equal to x. Now m equal to slope, that means slope of the tangent is dy by dx at the point of contact, and here this point of contact P is 1/2. So it is dy by dx is x, the value of x at P. That means this coordinates you will put here. So the x coordinate is 1. So m equal to 1, and at the same time we know that m equal to tan theta. You have to find theta. So substituting this value 1, here you get 1 equal to tan theta, and that means tan 45 degrees 1. So theta equal to 45 degrees. So 45 degree is your answer. The next question, the slope of the normal to the curve. So the curve is y equal to 2x square plus 3 sin x, and your question is slope of the normal to the curve at x equal to 0. At x equal to 0 means is a point of contact is given. So this normal ka slope you have to find out. This is the normal, and at the point means this is a point, that is the point of contact to the tangent. So at x equal to 0 means the x coordinate of this point P is 0. Y coordinate we don't know. Now how to find the slope of the normal? Slope of the normal is minus 1 by dy by dx at P. And from where you will get dy by dx? That is from the equation of the curve. So next you have to find out dy by dx. So it is very easy. This equation you have to differentiate and find dy by dx. So differentiating this equation with respect to x, you will get dy by dx directly as 2 into derivative of x square. Derivative of x square is 2x. 2 into 2x, that is 4x, plus 3 into derivative of sin x. Derivative of sin x is cos x. At the point P means we can say at x equal to 0. At x equal to 0 means how will you find out? You put x equal to 0 in this equation. So 4 into 0 plus 3 into cos 0. And that is minus 1 by cos 0 is 1. So minus 1 by 3. So D is the answer. The next is the slope of the tangent to this curve. The curve is given in the symmetric form. X and y are connected through a third variable t, and t is called parametric form. So here also you have to find the slope of the tangent to the curve. Curve's equation is given in parametric form, but slope of the tangent to the curve at 2 minus 1. So here is a point 2 minus 1 and slope of the tangent at this point. So here is a point of contact P. You have to find the slope of the tangent. That means m equal to dy by dx at P. And how to find a dy by dx is you have to apply the parametric form. This is dy by dt by dx by dt by applying the chain rule. So dy by dt means you have to differentiate this with respect to t. So 2 dy by dt is 2 into derivative of t square. So 2 into derivative of t square is 2t minus derivative of 2t is 2 minus derivative of 5 is 0. So dy by dt divided by dx by dt. You have to differentiate this with respect to t. So derivative of x, derivative of t square with respect to t is 2t minus derivative of 3t is minus 3 into derivative of t. So you are getting this. Now dy by dx at this. So you can see that now x is equal to 2 and y is equal to minus 1. So but you have got dy by dx in terms of t. So what we will do is you can just find out what is the value of t from here.